Okay guys, our objective today is to continue simplifying square roots without the calculator. So starting with our warm-up, which was mostly from yesterday's lesson. Donatus, what did you get for number 1? 4, and what else? There's another answer is what I mean. Good, so plus or minus 4. Number 2, Emma H. 3 point what? Okay. And you could also have left it as the square root of 15.6 if you did not use your calculator, because it's not a perfect square. So if you left it like this, that's fine. This is also the same thing. So either answer is fine. Okay, it just says solve the equations. Okay, number 3, the first 20 perfect squares. So Matt, the square root of 1 is what? Okay, Justin, what's the next perfect square? Square root of 4, which is, okay, Sean, what's the next one? Tell me, say it the right way though.
Square root of 9.
Good, square root of 9 equals 3. Briar, what's the next one? Good, Zach, next one. Nope, we're past that. After square root of 16. You can do it though. What's the next one? After square root of 16, so 16 is 4 times 4. What's the next one? Five times 5 is what? What's 5 times 5? We're on the one after 16. You just need to tell me what 5 times 5 is. Okay, so is the square root of 25 perfect? Yep, that's the next one. So square root of 25 is 5. Mary, next one.
The square root of 36 is 6.
Good. Adam, next one.
Square root of 49.
Good. Jeremy, next one.
Square root of 8 is 60.
You're saying it backwards. 8's not perfect. Okay, say the square root of 64 is 8. Doug, next one.
Square root of 81.
Good. Annalise, next one.
Square root of
Good. Okay. That's fine for now. I wanted it to be square root of, but same deal. You're good. Same deal. Matt, next one. Okay, manatee, next one. Good. Donatus, next one. Good. Square root of 144 is 12. Alyssa, next one. Good. Charles, next one. Perfect. Sean, next one. Good. Briar, next one. Good job. Emma M, next one. Good job. Adam, next one. Awesome. Justin, next one. Perfect. Mary, last one.
400 is the square root of 40.
Good. The square root of 400 is 20.
17 to 79 or
89. 289. All right. So eventually you're going to have a little quiz on those, and it might be timed. And I want you to know them both ways. And we're going to keep practicing them. Square root of all those numbers, but I also want you to know what each of those numbers squared is. So it's the same thing, it's just backwards. Briar? It's the same thing. That's why I said it's the same thing, but you'll see the list both ways. Donatus? I changed my mind. There's a reason for this. Not only does it help you with square roots, but when you factor next year in algebra and you factor with difference of perfect squares, you'll be really good at it. So I promise there's a reason for this. It's not just because I feel like giving you a timed quiz. I wouldn't do that. It's more work for me and more work for you. I wouldn't do that if it wasn't worth it. Okay? Matt, question? Or Manatee, question? Take a guess. Yes. Mary, is this a question? Okay. All right. Number 4 on the warm-up. So you just had to multiply these, okay? First one, You get 6 and 6. Second one, 12 and 12. Third one, 10 and 10. Fourth one, 24 and 24. Who can explain why? Why does it work that way? Whoever was paying attention yesterday. Why? Why does it work that way, Emma M?
Well, because no matter, like they're just going different ways.
Yep. Awesome. The product property of radicals tells us you can take a radical and you can split them up into square root of something times square root of something, which is still equivalent to square root of that something times something. These are always going to be the same value. Sean?
What is that? A again, square root of the A and square root of B.
A time symbol, multiplication. A little dot. No, little dot. Annalise? You thought this was a 4? You thought this was a 4?
Yeah, A, yeah. Values of A and B. For A, the square root is 2, and for B, it's 3. So I thought you had to multiply those to get 6 between the square roots.
No, because you don't ever think that, because you're just putting the 4 in for A, the 9 in for B. Take the square root of 4, you get 2. Take the square root of 9, you get 3. When you take the square roots are gone. You can't put them back on there. But you're still taking A and plugging in 4. No, because A and B are right here. A is 4, B is 9. So you're always plugging in the initial values. All right, let's talk about your test, then I'll go back to homework. The Chapter 8 test, there were a lot of A's. Very good. A lot of you guys really surprised me with how well you did. But I just want to take a couple minutes. You do not have to do corrections, okay? But what questions do you have for me? What answers do you need? Mary, we'll start with you. Yep. No, because what's wrong with that equation? Yes, it needs to be in slope-intercept form, and it's not. Okay? Anyone else on the Chapter 8 test? Questions or answers that you need? Doug, where's your test? You should be looking at it, not playing on your calculator. Jeremy, question? Okay, but you should always be getting A's or B's. Alyssa, I said always. 17. The slope is undefined because the 0 is in the denominator. So if 0 is in the denominator, it's a vertical line. Your slope is undefined. Okay, probably. Emma M. 19. Okay, 19. When you put it into slope-intercept form, you get y equals x plus 2. Slope is 1. Y-intercept is 2. So then you start at 2 on the y-axis, go up 1 to the right 1, up 1 to the right 1. Yeah, it's just the graph I took off of. This was worth 3 points. I only took off 1. Mary. 20 should be y equals negative 3/4 x minus 2.5. So your slope was right. You just have your b as incorrect. You plugged in the wrong points. It should have been x is negative 6, y is 2. You plugged in. Yeah. Anyone else need an answer? Have a question on the Chapter 8 test? You'll see it again when we get to the cumulative. No? We're good? Okay, if you guys are okay, carefully put those in your test folder and pass them up. Okay? Carefully put them in your test folder, pass them up. Don't drop them, please. You guys have a lot of stuff in those. Your test in there. Okay, and then let's go to practice 9.1. We're going to go over your homework. You just put it on top. Thank you. Yeah, apparently, since I'm all over the place. Thank you, guys.
How many points were 61?
How many points was what? 61. What are you doing? What do you need that for? All right, guys, practice 9.1. Matt, we're going to start with you, number 1. Sorry, manatee, number 1. I got to get used to this. Okay, hold on. Yes, well, actually, you're half right. Oh, no, 6 works. You're good. Sorry, you're good. Emma H, number 2. Good. Annalise, number 3. Yeah. Yeah, good. Doug, number 4. Good job. Number 5, Jeremy. Good. Mary, number 6. Good. Donatus, number 7. Good. About 6. Alyssa, number 8. Good. About -9. Zach, number 9. Good. About 10. Charles, number 10. Good job. Number 11, Sean. Good job. Number 12, Briar. Good job. Emma M, number 13. 2.24. Adam, do you have 14 done? No. Okay, Justin, 14. Just take your homework out, Adam, so you're following us. Good, -3.5. Zach, 15. Good, 10.1. Number 16, Alyssa. Good, Donatus, 17. Good, 39.8. 18, Mary. Good, 5.3. Jeremy, 19. Good, Doug, 20. Nope. Annalise, 20. Good, 9. Number 21, Emma H. Good, -96. Manatee, 22. Good job, plus or minus 8. 23 should be plus or minus 18. 24 plus or minus 15. 25 plus or minus 6.5. 26 plus or minus 12.2. 27 plus or minus 3.1. 28 plus or minus 4. 29 plus or minus 7.39. Jeremy, what's up? Gotta do 30. Good. Good job. 31, 172 feet. 32, 9.3 miles. Okay, before we go to the other homework, questions on this one. Mary. You should not have that. So on 29, you minus 8 from both sides. So you get 82 equals 1.5 t squared. Did you have that? You need to subtract 8 first. That's where you messed up. Add or subtract first, multiply or divide second. Think back to chapters 1 and 2. Jeremy, hold on. So, Mary, you should have subtracted 8 first. So you got 82 equals 1.5 t squared. Order of operations when you're simplifying an expression. When you're solving an equation, you add or subtract first, multiply, divide last. You're thinking of simplifying something. Order of operations is only used for an expression. Solving an equation is backwards of order of operations. So that's why, Mary, you want to add or subtract first on solving an equation, then multiply or divide. You okay, Mary? Okay, Alyssa? On 28, 29, 30, yes. Because when you're solving an equation, if that variable is squared that you're solving for, it definitely can be plus or minus. So only on that part would I take off on that. And we're going to do more of those. You guys should be good at them by the time we finish the chapter. Anyone else on that homework? Emma H? 31, it tells you a square ice skating rink has an area of 1,849 square feet. So you have to find the perimeter. First thing you have to do is find the side. So if you do side squared equals, you know what I mean? Square root both sides, you get 43 feet is the side, and then multiply that by 4. So easier than it sounds. Anyone else on the first homework assignment? Okay, let's go to 9.1 challenge, which was page 143. All right. Number 1, Sean, when you get there, let me know what you got. Good job. Number 2, Justin. Perfect. Emma M, number 3. Wow, very good, guys. Those ones are a little tricky. Now, Mary, these are order of operation problems because they're expressions, not equations. Well, I know that's because you've been following order of operations for everything. So my point is, on these ones, you should follow order of operations. The equation ones you got wrong do not follow order of operations when you're solving an equation, not when you're doing this, which are expressions. Okay? Jeremy, number 4. I thought you got to some of them. Okay. Donatus, 4. Okay, Alyssa, 4. You forgot to take the square root of both sides. So close. Manatee? Plus or minus? There you go. Emma H, number 5. Plus or minus, what'd you say? You're off a little bit. Annalise? Good. Plus or minus 1.41. Doug, number 6. Plus or minus 2 point what? 2.12. Okay, 7 less than. 8 equals 9 less than. Charles, 10. Just tell me, okay, keep going. Okay. Okay, you did not solve it right because you're off. Justin, what did you get for your answer? No. Sean?
Plus or minus 6.3245532.
Nope. Alyssa? Nope. Mary? Nope. Annalise? Nope. Doug? Emma H? No. Okay, let's just do this together. I'm surprised you guys actually got stumped on this. All right, so here's number 10. Go ahead, Manatee. No. Okay, number 10. Yes. Adam got it. All right, listen. Okay, on solving this equation, raise your hand. What's the first thing you should do? Zach, first thing. Okay, add 4 to both sides. Okay, step 1, add or subtract. This is back to chapters 2 and 3. 3 minus x squared equals 49. Okay, now what should you do? Sean? No, that's part of the problem, I think. What's up? Real quick. Justin, go ahead. Good job. To get rid of a square, square root both sides. This is the other part you guys messed up on. Square root it. 3 minus x equals 7. Okay. So Manatee, now what? Matt, please don't scare me. It is May, not September. Sorry, I keep doing that. calling in both names now. You gotta give me a couple of days. Like I messed up your names at the beginning of the year. Just give me a couple of times. So manatee, negative x equals 4. Now what? Good. So x is 4. Because it's 3 minus whatever x is. It can't be negative. This is not, Mary, it's not x squared equals something. It's 3 minus x squared. This one's very different. If you have negative 4 in there, it's not going to make it true. I'll show you. So 3 minus negative 4 is 3 plus 4, which is 7. Okay. 7 squared is 49. Oh, it does work. Oh, wait, that's because the answer is negative 4. Sorry. I meant to answer your question of why is it not positive 4, Mary? Sorry. 3 minus 4, if it's positive, Mary, you get negative 1. Negative 1 squared is 1. 1 minus 4 is negative 3. So if I wrote it down right and you asked it correctly, we're both wrong here. It's negative 4, but it can't be positive 4. Maybe. Let me deal with one new name first. Okay. I know. Questions? Guys. Doug, quit yelling out. Adam, quit yelling out. Okay. Questions on 9-1 challenge, which is page 143. Annalise. Because if a binomial is squared, you'll learn this in algebra, that means you write it twice and you FOIL, but I haven't taught you how to do that yet. Ignore that. All you guys know is to get rid of an exponent of a 2, you square root both sides. The rules of exponents are not that you distribute it. Do not ever distribute an exponent like that. Okay, that's more of an algebra concept. After this chapter, I would like to teach you polynomials if there's time. So I'll show you that. Go ahead. Well, the square root of 68 is 8.25. Okay. Mary.
Aren't like regular equations?
Uh-huh.
Do you still follow OO?
No, you never follow OO with equations. Never. Order of operations is for expressions, not equations. Order of operations is just from chapter 1. That was before I introduced equations to you. You're just getting it mixed up because we haven't done it in a while. We're getting back to the cumulative here soon, so we will revisit all of that. Okay? Because you need that for next year. What, Alyssa? I don't know yet. We'll see. I got to figure that out. All right. Anyone else on the homework? Okay, open up your notes to page 4. So we started this a little bit yesterday. I want to finish this today. Simplifying radical expressions. Notes page 4. I'll wait till you guys all get there. I always mix up the colors. I just randomly pick whatever colors I'm in the mood for. So I guess I should try to do that. The bright colors always be the notes. Sorry, Jeremy. I just like to have colors because it's fun. Different than white all the time. All right, so we're going to start with example 1, letter A. Okay, before we get to this, we're going to write down the first couple perfect squares, okay? Square root of 1 is 1, square root of 4 is 2, square root of 9 is 3, square root of 16 is 4, square root of 25 is 5, square root of 36 is 6, square root of 49 is 7, square root of 64 is 8. Okay, I'm going to stop there. So there's at least some perfect squares. So here's how we simplify using the product property of radicals. You need to take the number that's inside the radical and split it up into square root of something times square root of something. One of those numbers has to be a perfect square. We are simplifying without using a calculator. Sean, put the calculator down. We are simplifying without changing it to a decimal. So here's how I'm going to ask this. What is the largest perfect square that can be divided into 32? Charles. Good. How many times? Okay. Square root of 16 times square root of 2. Now, What else would work? And I'll show you why we're using the largest perfect square. Briar, what else would work? Okay, so let's do it both ways, and then you'll just trust me. It's easier to use the largest perfect square that divides into it. You don't have to, but it's easier. Okay, circle what's perfect. Jeremy, what's the square root of 16?
4.
Doug, can we take the square root of 2 without a calculator? No. So our answer is 4 times the square root of 2. That is completely simplified. So that's using the largest perfect square. Bless you. Let's use just the random square root of 8 times square root of 4. Circle the square root of 4. It's perfect. The square root of 4 Donatus is what? Adam, you with me? Rewrite the square root of 8. Why is this not simplified yet? Why is this not simplified yet? Jeremy? What can be squared? You have to say it correctly. The 8 what? How? I already said that. I said, how can it be simplified further? How? Mary, help him out. Eight can be broken down into square root of 4 times square root of 2. 4 times 2 is 8. In other words, there is still a perfect square that can be divided into 8. I'm going to circle this. The square root of 4 is perfect. Okay, I'm going to rewrite this 2. The square root of 4 is 2. And I'm going to drop down square root of 2. Adam, what's 2 times 2? So, you have the annoying long way of doing it, which is this way. And you have the quick, much more simple way of doing this. Trust me, if you use my advice and find the largest perfect square that can be divided into that number, you will save yourself a big headache as well as mistakes. Because doing it the second way, look how much longer that was. Do you guys see what I'm talking about? Okay, so if you find the largest perfect square that can be divided into that number, much easier. You'll still get the same answer. So if you don't agree with me or if you don't like that, you don't have to do it that way. Yes, Annalise?
I have 2 things. Why do you put last line 2 times 2 square root of 2 is?
The square root of 4 is 2, and you have to drop down this 2.
And also, how come the square root of 2 times 4
I'm not sure what you're asking. Annalise, we did this 2 ways. So this way was 8 times 4 is 32. You with me? Square root of 4 is 2. We rewrote the 8. We then broke down the 8 into square root of 4 and square root of 2. Yeah, it's the same thing.
I was wondering if the square root of 32, I thought it was just 32 and the square root of 2 times 4 but it's the square
Right, right. Yep, it does. I wouldn't do it if it didn't equal it, I promise. I will not show you things that are not equivalent. Okay, letter B, square root of 24. What is the largest perfect square that can be divided into 24? Emma H. How many times? Okay, I gotcha. I thought you just said 6. Gotcha. 4 is the perfect square that goes into 24. It goes in 6 times. Justin, which one of those is perfect? Good. Circle the 4. It's perfect. Zach, what's the square root of 4? Good. Adam, can this be simplified any further? No. There is not a perfect square that can be divided into 6. If you use your calculator and type in 2 square root of 6, it is the same decimal as square root of 24. But we are not leaving our answer at the decimal. We are keeping it exact. Jeremy? Yes. Correct. If you do 12 and 2, it's getting you nowhere. You're just going to go run around in circles like crazy. Annalise. Is 2 a perfect square? No. 2 is not a perfect, the square root of 2 is not a nice number because there's nothing we can take that you can multiply by itself to get to 2. Huh. Okay, letters C and D I want you guys to do. C and D I want you guys to do. Do not do E yet. Charles, I hope you know what you're doing on this. Shh, quiet. C and D on your own. Okay, since most of you are done, I'll give you another minute. That's not right, so don't do it without me, okay? At least here, you're not done yet. Are you done with it? Okay, that's not completely done. Just let me do one, Charles, then you can go ahead. All right, you're good. You can keep going. Donatus. You're no fun, Donatus. I want to explain it to you. I'm just kidding. What's up? You just didn't want me to check? This is not right. So erase this. Which one of these numbers is perfect? Okay, circle it. That's the square root of 100. So that goes in front. Okay. Yeah. Very good. What happened here? Where'd the 10 come from? You have to have 2 integers that go into it. Think about $2.75. What perfect square goes into $2.75? Think of money. 25. Think about a quarter. Awesome. All right, most of you guys are just about there. No, stop. You're not supposed to go that ahead of me. You're not doing some of these right. Stop. Yes, Annalise. Yep, you're good. You're good. Much better. All right, letter C, Adam. What 2 numbers can we break this down into? What? Tell me. If you did it yesterday, what perfect square goes into 300? What's your answer on your paper? For letter C? 75 still has a perfect square that goes into it. So Adam, this is why don't go ahead of me. Find the largest perfect square that goes into 300. It ends in 2 zeros, so 100. Adam, how many times? 3. You with me? What you used would have worked, but you're not completely simplified. So 100 is the largest perfect square that goes into it. Circle the perfect square, take the square root of it. Square root of 100 is 10. Rewrite the number that's not perfect. That's your answer. 25 is not the largest perfect square, but it still works, but you have to keep going. Okay. All right, letter D, Sean. What's the largest perfect square that goes into it? How many times? Nope.
Oh, sorry.
More than that.
11.
Look at your paper. There we go. I was going to say, look at your paper. 25 times 11. You guys can't multiply today. Is 275. Donatus, which one of those is perfect? Good. 25 is perfect. I'm going to circle it. Square root of 25 is 5. Drop down the square root of 11. Yeah. It's really not bad once you understand the concept. Questions on just numbers before I get into variables? Okay, letter E. The square root of 25x squared. So here's my rule with exponents. When you have a variable, and it has an, make sure you guys are listening. When you have a variable, Doug, it has an even number exponent. It's a perfect square. When you have a variable and it has an odd number exponent, it's not perfect, but we can make it perfect. So I'll say that again. When you have a variable with an even number exponent, it's perfect. When you have a variable with an odd number exponent, it's not perfect, but we can make it perfect. So letter E, we're going to split up into square root of 25 times square root of x squared using the product property of radicals. So square root of 25 is perfect. I'm going to circle it. We know any variable to an even number exponent is perfect. Donatus, how do we take the square root of a variable with an even number exponent? Yeah. So but here's a shortcut. Divide the exponent by 2, and that's how you get the perfect square. 2 divided by 2 is 1. So the square root of x squared is x to the first. What's x times x? Charles? Yeah, check it. X times x is x squared. The square root of x squared is x to the first. The shortcut is when it has an even number exponent divided by 2, that's how you take the square root of it. 5x times 5x is 25x squared. So your answer is 5x. Emma H. No, I'm just trying to explain it. No, I don't do all that. I'm just trying to explain so you guys understand it. Do you understand it? Okay, making sure. Jeremy, question, go ahead. No, your calculator stores x as a value. Not true. Okay, making sure you knew that. Emma.
So instead of putting 5x to the first, can we just put 5x?
Yes. Okay. Who can raise their hand and tell me? Don't yell it out. What's the square root of 49y squared? Raise your hand when you know. Square root of 49y squared. Quiet. That's not a cube. What's the square root of 49y squared? I'm not on that one. I'm asking you, what's the square root of 49y squared? I'm on a different one. Annalise. Good, 7y. Okay, raise your hand when you know this one. What's the square root of 144x to the 8th? What's the square root of 144x to the 8th? Uh-oh, not as many hands this time. Oh, come on, I know it's early. Charles? Tell me why. How'd you get x to the 4th? Good. 8 divided by 2 is 4. When you have an even number exponent, it's perfect to take the square root of this, you divide this number by 2, and you get 4. Annalise. Yes. Awesome. Nice job thinking back a couple chapters ago. Doug. We're not on that one right now. Doug, stay with me. Questions on this one or this one? Okay, so the reason I did that is because letter F is a little bit different. If you have an odd exponent, okay, we can make it so it's perfect. So Annalise kind of brought up the next point here that I was going to start talking about. What can we change y to the third to? So it's y to the something times y to the something, but one of them's perfect. Justin? What's the other one? Okay, who can tell me? I know you know, Justin. Who can tell me besides Justin, why does that work? Emma H. And why else? Yeah. When you multiply same base, you add exponents. We are not changing the value. We're just writing it so one of them's perfect. This is perfect. This is perfect. This gets dropped down. Square root of 49 is 7. Manatee, what's the square root of y squared? Good. Square root of y drops down. Jeez. You know, sometimes I have such a problem with writing things. Sorry. I do that. I think about what I want to ask you guys, and then I write the completely wrong thing. Okay. Annalise. Yep. Always. Just like the numbers that aren't perfect. Just drop them down. All right. I want you guys to try I and J. I'll give you a minute. I and J. And then I need to show you one more type. Shh, just I and J. Yeah, there's pretty easy. Just try I and J. Where are you going? Got it. You're about to fall asleep on me here. Good. Make sure those get mushed together. The square root of 15c should be in one radical. 4 goes into that if you need help. Make sure you guys are finding a perfect square that goes into the numbers. Whoa, 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 whoa. Why are you changing that to a decimal? You need to find the perfect square that goes into it. No decimals. Yeah. No decimals. Yes, there is. You need to find a perfect square that goes into 60. No decimals. When you're simplifying radicals, no decimals. On 9-1, Annalise, that was just an introduction to square roots. No decimals when you're doing this. Make sure you guys are going through your list of perfect squares. There's a perfect square that goes into 60. There's a perfect square that goes into 120. All right, Justin, what perfect square goes into 60? How many times? Good. So guys, 60 can be broken down into 4 times 15. Please don't forget about what perfect square goes into it. B squared is perfect. I'm just going to rewrite it. C just stays there. So 60 can be broken down into 4 times 15. Do not change it to a decimal, and don't forget about perfect squares. Annalise. No, you can, just like we did square root of 25x squared, just like we did square root of 49y cubed. Say that again. We're not done. Square root of 4 is 2. Square root of b squared is b. And then 15 and c are not perfect, so they just get dropped down. Annalise. Yes, that's not very nice. You got to make it all look a little bit nicer so that it's completely simplified. Matt, Manatee. I would like you to take one more step and put them together. It's not wrong, but it still is not the way it should be. Yes, Annalise. That's what Matt just asked. No, you need to have it together. They're not perfect. So they stay inside one radical symbol. Okay, Doug, what perfect square goes into 120? How many times? Good. Okay. Briar, what's perfect here? What can I circle? What else? Good. Okay, so I'm going to circle everything that's perfect. Square root of 4 is 2. Square root of h squared is h. Square root of j squared is j. Leave the square root of 30 inside the radical. That cannot be broken down any further. I'm going to give you guys one more. Questions on that one? Okay, let's do this one together. Oh, let me go. Okay. Square root of 45 x to the 9th, y to the 20th. And put a -2 in front. Last problem. I really don't have much time, but -2, and then square root of 45 x to the 9th, y to the 20th. Okay, I know, making you guys think. What perfect square goes into 45? Okay, raise your hand next time. So leave the -2 in front. 9 goes into 45. Emma H, how many times? Good. Annalise, x to the 9th can be broken down into what? Nope. It can be, but that's not helping you. You want the highest positive number times an odd, or sorry, the highest even number and then the odd number that's left over. Good. Mary, what should we do with y to the 20th? No. An odd number exponent's not perfect. You're thinking of it as square root of 9. It's square root of x to the 9th. An odd exponent is not perfect. It has to be an even exponent. So then y to the 20th just stays here because it's an even number. It's perfect. The exponent rules are different, Mary. If it's even, it's perfect. If it's odd, it's not. Okay? So we have square root of 9 is perfect. Square root of x to the 8th is perfect. Square root of y to the 20th is perfect. What are we doing with this negative 2 in front? Charles? Yeah, and then what's going to happen when I take the square root of 9? Good. So it's going to be negative 2 times the square root of 9 is 3. Doug, what's the square root of x to the 8th? Good. Manatee, what's the square root of y to the 20th? Good. Wait, say that again? What's the square root of y to the 20th? Good. Divide it by 2. What do we do with the square root of 5 and the square root of x? Sean? Combine them. So, mush the answer together. What's the final answer? Adam? Where'd you get 5x to the 5th? You mean just 5x? You were so good until that last part. Annalise, hold on 1 second. All right. Let me explain homework first, then I'll answer questions. All right. I want you guys to open up your homework packets, page 136. I'll answer questions in a second. Homework packet, page 136. Okay, here's what 136 looks like. Okay, 1 to 16. Find the largest perfect square that goes into it. Okay? Annalise, go ahead. Sorry. Yes. It has an odd exponent. If it has an odd exponent, it's not perfect. Yeah, but the square root of x is square root of x. The square root of 1 is 1, but it's square root of x to the first. X to the first, even though 1 is a perfect square, it follows the exponent rule. That's what Mary was asking about, x to the 9th. The exponents are only perfect if it's even. Okay? Mm-hmm. Yep, so just subtract 1, whatever the closest even number is. Just subtract 1. Did everyone find homework, page 136? Okay, let's get packed up. I'm late today. Again.